What if I told you that every planet in our solar system is not just a distant world, but a separate timeline of travel, where reaching some takes months while others take years, and some journeys may even outlive the spacecraft itself? From Earth, we look at planets as tiny dots in the night sky, but behind those dots lies a terrifying truth. Space is not empty. It is a battlefield of distance, gravity and time, where every kilometer demands patience beyond human imagination. This documentary will take you through the real travel time from Earth to each planet, and what actually exists on those worlds, from burning atmospheres to frozen oceans, from giant storms to landscapes so alien they rewrite what we know about reality. As we begin this journey, you will understand why humanity has only scratched the surface of our solar system, and why every mission sent outward is not just a trip, but a fight against distance itself. Now let's begin our journey with the closest and one of the most extreme worlds in our solar system, Mercury. Mercury is the closest planet to the Sun, but paradoxically, it is not the easiest to reach. Spacecraft do not travel in straight lines in space, because gravity constantly reshapes their path. Reaching Mercury from Earth typically takes around 6 to 7 years, depending on the mission design, even though it is only about 77 million kilometers away at its closest point. The reason for this long journey is the Sun's gravity, which pulls spacecraft inward, making it extremely difficult to slow down and enter Mercury's orbit without complex orbital maneuvers and gravity assists. Mercury itself is a world of extremes. It has no atmosphere to trap heat, so one side burns at over 430 degrees C, while the other side plunges to minus 180 degrees. It is covered in craters similar to the Moon, showing billions of years of impact history. Its surface is made mostly of rock and metal, suggesting it may have once been much larger, before losing its outer layers due to massive collisions. Spacecraft approaching Mercury would face intense solar radiation and heat, but also reveal clues about the early formation of the solar system, making this small planet one of the most scientifically valuable destinations, despite its difficulty in reach. As we move away from the Sun, we enter a world that looks similar in size, but is completely different in reality, Venus. Venus, often called Earth's twin due to its similar size, takes around 5 to 6 months for a spacecraft to reach under optimal launch windows, but entering orbit or landing is a far more dangerous challenge than distance alone. The planet is wrapped in a thick, toxic atmosphere composed mainly of carbon dioxide with clouds of sulfuric acid, creating a runaway greenhouse effect that makes its surface hotter than Mercury even, though it is farther from the Sun. Surface pressure on Venus is about 92 times stronger than Earth, which means any spacecraft landing there would be crushed within hours or minutes. Its landscape includes vast volcanic plains, extinct lava flows, and possibly active volcanoes, suggesting that Venus may still be geologically alive below its hostile skies. The thick atmosphere also blocks direct visual observation, making radar mapping essential for studying its surface. A journey to Venus is relatively short in cosmic terms, but what awaits is a world that feels more like a planetary furnace than a place for exploration. Yet it remains one of the most important targets for understanding climate, runaway effects that could one day mirror Earth's future. After the burning skies of Venus, we now turn towards something much closer to home, Earth's own moon. The moon is the closest celestial body to Earth and takes only about 3 days for spacecraft to reach, using modern rocket technology. But this short journey should not deceive us into thinking it is simple. The moon is a rocky, airless world covered in dust and impact craters with a surface unchanged for billions of years because it lacks atmosphere and weather. Its near side is familiar to humanity, but the far side remained hidden until space missions revealed its heavily cratered and mysterious terrain. The moon holds frozen water and permanently shadowed craters near its poles, which has become one of the most important discoveries. For future lunar bases, spacecraft traveling to the moon must carefully enter precise orbital paths to avoid crashing into its surface, and even small errors can be fatal despite the short distance compared to other planets. The moon is not just a destination, but a stepping stone for deeper space exploration, serving as a training ground for missions to Mars and beyond. From the familiar lunar surface, our journey now stretches farther into the red and mysterious world of Mars. Mars is one of the most studied planets and takes about 6 to 9 months for spacecraft to reach, depending on orbital alignment between Earth and Mars, a factor known as launch windows, which occur every 26 months. Mars is a cold desert world with a thin atmosphere, mostly made of carbon dioxide and surface temperatures that can drop to minus 125 degrees C at the poles. It is home to the largest volcano in the solar system, Olympus Mons, and a canyon system, Valles Marineris. that dwarfs Earth's Grand Canyon. Evidence suggests Mars once had liquid water rivers, oceans, and possibly conditions suitable for microbial life billions of years ago. Today, it is dry and dusty, but still holds ice beneath its surface and seasonal methane releases that continue to puzzle scientists. Spacecraft exploring. Mars must endure long communication delays due to distance and survive entry through its thin atmosphere using heat shields and parachutes. Mars represents humanity's next major step in planetary exploration and possibly future colonization, making it one of the most important destinations in space history. Leaving the rocky inner planets behind, we now enter the giant outer world dominated by Jupiter. Jupiter is the largest planet in our solar system, and reaching it from Earth typically takes around 1 year for fast missions, but can extend to 2 or more years depending on trajectory and gravity assist, because spacecraft often use planetary flybys to gain speed instead of direct travel. The journey is long, not just because of distance, but because navigating the sun's gravitational field requires carefully planned curves rather than straight paths. Jupiter itself is not a solid planet in the traditional sense, but a massive gas giant composed mostly of hydrogen and helium, with no clear surface to land on. As a spacecraft approaches, Jupiter at first encounters intense radiation belts far stronger than anything around Earth, which can damage electronics and systems within hours if unprotected. The planet's atmosphere is a swirling chaos of storms, including the famous Great Red Spot, a storm larger than Earth that has been raging for centuries. Beneath its thick clouds, pressure increases until hydrogen may turn into metallic liquid, forming strange internal layers that behave unlike anything found on Earth. Jupiter also acts like a cosmic shield for the inner solar system, capturing or deflecting comets and asteroids with its immense gravity, making it a key protector of Earth's orbital environment, despite being unreachable as a landing destination. Jupiter holds immense scientific value, especially through its moons like Europa, which may hide a subsurface ocean capable of supporting life, making the journey to Jupiter not just a trip to a planet, but a gateway to multiple worlds beyond. Jupiter's massive storms and radiation belts, another giant waits in silence. Saturn. Saturn takes approximately 3 to 4 years for spacecraft to reach, depending on mission design and gravitational assists, and like Jupiter, it cannot be landed on due to its gaseous composition, but it remains one of the most visually stunning destinations in the solar system. The planet is famous for its massive ring system, made of ice particles, rock and dust ranging in size from tiny grains to mountains floating in orbit around the planet. These rings are surprisingly thin, yet extend hundreds of thousands of kilometers, creating a structure unlike anything else in space. Saturn itself is a gas giant composed mostly of hydrogen and helium, with extremely low density, so light that it could theoretically float in water if a container large enough existed. Its atmosphere contains powerful storms and wind speeds reaching over 1,500 kilometers per hour, making it one of the most turbulent environments known. Its moons are equally fascinating, especially Titan, which has rivers, lakes, and seas of liquid methane and ethane, and a thick nitrogen atmosphere resembling early Earth conditions. Enceladus, another moon, ejects water vapor geysers from its icy surface, suggesting a subsurface ocean beneath frozen crust, making it a potential habitat for life. Spacecraft reaching. Saturn must survive years of deep space radiation exposure and rely on precise navigation. But the reward is a system of worlds that feels more like science fiction than reality. As we travel deeper into the cold outer solar system, we encounter the tilted and frozen world of Uranus. Uranus is one of the most distant planets, visible to spacecraft missions, and takes about 7 to 8 years to reach from Earth due to its distance and slow orbital position in the outer solar system. It is an ice giant composed mainly of water, ammonia, and methane in supercritical states, forming a deep, cold atmosphere that gives the planet its pale blue color due to methane-absorbing red light uniquely. Unlike other planets, Uranus rotates on its side with an axial tilt of about 98 degrees, meaning it essentially rolls around the sun rather than spinning upright, creating extreme seasonal variations that last for decades. Its atmosphere is extremely cold, reaching temperatures below -224 degrees C, making it one of the coldest planetary environments in the solar system. Despite its calm appearance from a distance, Uranus has hidden storms and dynamic cloud systems beneath its haze and faint ring system made of dark particles. Its moons, such as Miranda, display strange fractured terrain, suggesting past geological activity that reshaped their surfaces in chaotic ways. The long journey to Uranus is a test of endurance for spacecraft, as solar power becomes Week and communication delays stretch into hours, but studying this planet helps scientists understand ice giant formation, which is also common in many exoplanet systems beyond our own. Beyond Uranus lies the darkest and windiest planet in our solar system, Neptune. Neptune is the farthest known major planet from the Sun and requires around 12 to 13 years for spacecraft to reach, making it one of the longest journeys ever attempted in planetary exploration. It is another ice giant, similar to Uranus but with a more dynamic and violent atmosphere, featuring the fastest winds in the solar system reaching up to 2,100 kilometers per hour. Despite receiving very little sunlight, Neptune emits more internal heat than it receives, suggesting complex internal processes still not fully understood. Its deep blue color is intensified by methane in its atmosphere and active storm systems, such as the Great Dark Spot observed by spacecraft like Voyager. Neptune also has a collection of moons, including Triton, which is unique because it orbits in the opposite direction of Neptune's rotation, suggesting it may have been captured from the Kuiper Belt. Triton has geysers that eject nitrogen gas, indicating possible geological activity beneath its icy surface. Spacecraft traveling to Neptune face extreme isolation from Earth with minimal sunlight and extremely long communication delays, but the data gathered from such missions helps reveal how planetary systems evolve in the cold outer reaches of star systems. And at the far edge of our known planetary system, we reach a distant icy world once called the ninth planet, Pluto. Pluto is no longer classified as a full planet, but as a dwarf planet located in the Kuiper Belt, and reaching it from Earth takes approximately 9 to 10 years, as demonstrated by NASA's New Horizons mission, which flew past it in 2015. Despite its small size, Pluto is a surprisingly complex world with mountains of water ice, vast nitrogen plains, and a thin atmosphere that expands and collapses, depending on its distance from the Sun, its largest moon. Charon is so large relative to Pluto that the two bodies orbit a common center of gravity, creating a binary system unlike most planet-moon relationships. Pluto's surface shows signs of geological activity, suggesting that even distant icy worlds can remain active far longer than expected. Its landscape includes frozen plains like Sputnik Planitia, which appears smooth and young compared to surrounding cratered regions, indicating resurfacing processes still occur. Pluto exists in a region filled with other icy bodies, making it part of a vast cosmic frontier that marks the edge of our known planetary system, and reaching it requires patience across nearly a decade of interplanetary travel. After traveling across the entire solar system, we finally understand just how vast and extreme our cosmic neighborhood truly is. When we look at all these journeys together, from Mercury taking years to reach due to gravitational challenges to Pluto requiring nearly a decade, the reality of space exploration becomes clear. Distance in space is not measured only in kilometers, but in time, energy, and human patience. Spacecraft do not simply fly straight to their destinations, but follow complex gravitational pathways that stretch travel times far beyond what intuition suggests. Even the fastest human-made objects struggle against the scale of the solar system, where planets are constantly moving and alignment windows open only at specific intervals. This is why every mission is planned years or even decades in advance, and why each successful arrival represents not just engineering success, but survival through an immense journey across darkness, radiation, and silence. From the scorched surface of Mercury to the frozen edge of Pluto, every planet tells a different story of time, distance, and extreme environments that challenge everything we know about survival and exploration. Spacecraft traveling through this system are not just machines, but messages from humanity, proving that even across billions of kilometers, we are capable of reaching out into the unknown. The solar system is vast, violent, and beautiful, and every journey outward reveals not just new worlds, but also a deeper understanding of our own fragile planet floating in the same cosmic ocean.